So hopefully it will do better now. We are recording. This was example 1, which we had already done. We had done example 2. Oh, I meant to do the announcements too. This one's, I think, fairly important. I don't know if it will apply to you, but I think it certainly spread it among your friends, even if it doesn't directly apply to you. Tomorrow there will be 4 informational sessions offered. Okay? The topic is institutional scholarships and summer Pell. Okay? I think I told you all this before. The Pell Grant, about 7 or 8 years ago, it seems like, they tried doing Pell Grants in the summer. In other words, you apply in the spring, and hopefully if any of your own Pell, you've already applied. Okay, and if you applied already, even if it's approved and everything, for the last 7 or 8 years, you couldn't start it until fall. And then most of the time, if you're a full-time student, you used it up fall and spring, and then usually wouldn't have any money left for summer. Now, if you're part-time, you may have had money left for summer. But full-time usually would use up the Pell, and then summer had no Pell. Well, about 7 or 8 years ago, they tried, when students apply in the spring, getting it approved and then letting students use that Pell in the summertime. And it worked tremendously well. We had record attendance in summer. It was fantastic. The students could use a Pell in the summertime. And after just a year or two of that, I think Congress had midterm elections and they shut it down. Okay, I'm not sure that was what it was, but it seemed like it coincided with that. So we went back to starting it in the fall. Well, for some reason this year, they're starting Pell in the summer again. Now, time out again. All along this time, before they tried the experiment and when they were doing it, and since then, when it failed, or not failed, but they quit doing it, the college tries to have some funds available. We always have some summer scholarship money available. We go to our foundation and everybody else that we can try to get scholarship money. They do fundraisers and things like this, so there is some money available in summer, always has been. So students who don't have the Pell, they can maybe take 1, maybe 2 classes. Well, all that institutional money is still there, plus now Pell's going to be here, so we should have more money than ever this summer. If students can do Pell, and if not, apply for the some institutional scholarships. That's what the informational session is about, telling you when the deadlines are, which I think are coming up within the next 2 weeks. I think around the 15th, so it may only be about 11 days away. So if you do qualify for Pell, please get that running. If you don't qualify for Pell, then you can apply for an institutional scholarship. These 2 sessions will be tomorrow. I say 2, there's 4 sessions. Tomorrow, April the 4th, at 11 to 1, that's 1 session, and 5 to 6:30, that's a session. But they're on both campuses, so you see there'll be 4 sessions going on. So if this Birmingham campus, Bessemer campus is more convenient for you, you can do either 11 to 1 or 5 to 6:30. But if you're over on the Birmingham campus in one of those times, you can do either of those times there. Here on this campus, it will be in the faculty staff dining area. Now, I'll tell you this right off the top. I don't know if any faculty or staff still uses that as a dining area. There may be some that do. Most of us eat in our office or go off campus to eat or something. No one seems to use that anymore. Back when I first started here, it was very popular and people used it. But of course, back then we were a Bessemer State Technical College, and back then we had to swipe in and out every time we came and left thing, and you had to get in your hours. So most people ate on campus. They didn't go off campus because they got their lunch hours if they did. So to get to the faculty staff dining room, you go out of this door, go down this long hallway here, past the first stairwell, at the second stairwell, before you get to the end, it's about 2/3 way down, stop, take a left, go down the first half flight of stairs, and then you're on this intermediate level here. Go straight ahead, then you have to make a zigzag here, and then going toward the cafeteria, the faculty staff dining room is just before you get to the cafeteria. On on the left. Okay? And that would be both times 11 to 1 and 6 to 7, 5 to 6:30. Yeah, 5 to 6:30. Now, on the Birmingham campus, these are in the Leon Kennedy Center. This is on the Birmingham West campus, the Leon Kennedy Center, which is, some call it the Student Center, and it's in the cafeteria. And 11 to 1 is the main cafeteria lunch hour there. I don't know how many people there. Most times when I've been there around then, they've been pretty well used. So I don't know where they're going to have it. They'll probably get the far end somewhere down there and just have the meeting down there. Then 5 to 6:30, that's when the residence hall has their evening meal, but that's a much smaller crowd, so that shouldn't be any problem. But anyway, there'll be 2 sessions on both campuses tomorrow, okay, sponsored by Office of Student Financial Services. Math team's still looking for good folks, and y'all are good folks, so if you can, they practice every Friday at noon and every Monday at 3 in the Science Building on the Birmingham West campus, which is the C Hall C100. And Mr. Rossi is always looking for participants, okay? Tutoring, now you can both get tutoring, but you folks, I think, would be better as acting as tutors. On this campus, if you go down to that second stairwell, don't go down the stairs. On your immediate right is our tutoring center. If no one's in there, continue on down the long hallway till you get to the end, hang a left, and the last office on the right is Student Support Services. You can inquire there about either receiving tutoring or becoming a tutor. That's Student Support Services. Or go down to that second stairwell. This time go all the way to the first floor. When you come around the corner, the Space Center is right there, and they have tutoring, and they also need tutors. So check with them there. Okay. Any questions on anything we've done up till now? Okay, we're making decent progress through Chapter 5. We're on 5.4 now. We only have one more section to do, and we'll have our third test. Okay? So need to get those other tests, keep them coming. And this, of course, my best class ever, right? I haven't received a single research paper yet. The only class that I require research papers in that I haven't received at least one. I may be wrong on that, but let me just check here. I know this class has. This may be shaming you. Yes, even my second mini-term class, I've received at least one paper. Hint, hint. Okay, get those papers in. This spring break, we were going to be working on those, weren't we? Okay? Okay. I'm glad you're making good progress. Just get them turned in. Okay? What's that? I can't hear. Okay. That'll be fine. Just get them to me. Don't forget about it. Okay. Let's move on to any questions. Okay. We're on example 4, but they only gave example 1 in the text, and then they skipped 2, 3, and 4. They do example, in the PowerPoint, they do example 5, so we'll go back to the PowerPoint as soon as we finish example 4. Okay. Here's an application of the sum formula. Of course, we remember this really well, right? Okay. It says, write this. The cosine of the arctangent of 1 plus the arccosine of x. As an algebraic expression. In other words, your answer is going to have some x's and other things in it. How do you do that? Looks a little daunting, doesn't it? Okay? I just wanted to remind you of a couple things. Where do we take the cosine off? What are those things we take trig functions of? Angles, okay? Now, what do you take the arc or inverse of a trig function of? Okay, what do you get when you take a trig function of an angle? What does it produce? Just a number, right? So what do we take the inverse trig function of? A number, and it produces an angle. So that's an angle, and that's an angle. And this is the sum of two angles, right? Okay. All right. Now, I'm trying to figure out where is going to be the most logical place to do this. I think let's just go on and do it. Now, I just don't care for arcs in general. Inverse is not very much, but arcs I really don't. Let's express what in the world that arc tangent 1 is. Does anyone know what it is right off the top? Okay. That means, oh, and this is, you just told me, what is this? Arc tangent 1? That is an angle. Okay? So let's just say it's this angle right here. You want to give it a name? A. Okay, we'll make this little a. Is that okay? All right. Quite often when you do little a for that. Now, what does arctangent of 1 mean? What the tangent of this angle A is what? From our old hymns. Opposite, which is the y value over the adjacent, and that's why I may be able to, let me just go back to y and x's, because A could mean adjacent. So it's y over x, right? And at what angle is that ratio of y over x equal 1? If x is equal to y, then what angle is that? Second? Okay. That's angle 0, that's pi halves. Where is it that the x and y are going to be equal? 45 degrees, which is also pi fourths. Okay, spring break's clearing out now. So this angle here is pi fourths. You agree? Okay. Now, this one has an x in it. So let's do this. Arc cosine of x. In other words, that is an angle. What do you want to name that one? Second? B. Okay, this will be angle B. So let me just draw in B here. Okay? Now, what is B in terms of adjacents and adjacents, opposites, and hypotenuses? Is what? Adjacent over hypotenuse. Now this time I will go back to the A's here. This is not the same as that A. A, O, and H. So that would be that angle B, the cosine of angle B is adjacent over hypotenuse. Okay. But we also know that is x. Okay. Now don't confuse that x with this x, okay? Okay. All right. So that angle is B, and its cosine of that angle, cosine of B is equal to x, right? Okay. Now, but that's some angle B. Okay, so here we have the cosine of pi fourths plus B. Now, by our sum angle formula, which of course we remember, what is that? A little louder. Cosine, the first one, which will be pi fourths, times cosine B, which is over here. In fact, on this one, let's not change that. I think it was better on the first one, but let's leave this as cosine of arc cosine x, okay, minus sine of pi fourths, that's a fourth, okay, times sine of, now what do I want to call that? Let's call this one B, okay? All right. There's a method to this madness. What is cosine of pi fourths? Oh, a lot of silence in the room. Yes, the square root of 2 over 2, okay? Now, what's the cosine of the arc cosine of x? In other words, if this ratio, if the cosine of b is equal to x, and that's the adjacent over the hypotenuse, then the cosine of b is, this tells us that arc cosine of x is equal to b. This tells us that cosine of b is equal to x, right? And that's what we're doing here. Cosine of b is equal to x. Okay. Because the cosine undoes the arc cosine, so this is just x. Minus, and sine of pi fourths is square root of 2 over 2. And sine of b, well, let's go back to our b here. Okay. All right. What is the cosine of b? I mean, the sine of b in general. From this figure here, sine of b is equal to opposite over hypotenuse, right? Okay. Now, we need that in terms of x, okay? And we know that or do you agree with this, that adjacent is equal to h times x? Right? Okay? Now, since I have an h here, I want to solve for h, so let's divide both sides by x. Okay? Now, this is probably the easiest way to do it, but it's one way to do it. H is equal to a over x. Okay? Now, sine b is opposite over hypotenuse, but hypotenuse is this, so that would be opposite over a over x, right? Which would be opposite times x over a, okay? And opposite over adjacent is what? Tangent. Okay? So that would be the tangent of B. But we don't know anything about the tangent of B. Sorry. We can't use this one because that was the tangent of 1. That's a different angle. That's pi-4. Okay, let's try a different approach here. Okay. We know that we know cosine of B is equal to x over A is equal to x, right? Okay. Yeah, this is the way we do it. And we also know, so forget all this, okay? This was all true, but it wasn't helping us any. Okay. Okay. We know cosine B is equal to x. What we want to know is sine B, right? Well, what's the relationship between sine B and cosine B? Think Pythagorean. Sine squared B plus cosine squared B is equal to 1. But cosine B is x. So this will be sine squared B plus x squared is equal to 1, right? So therefore, sine squared B is equal to 1 minus x squared, right? And sine B would then be the square root. You really should say plus or minus the square root of 1 minus x squared. All right, let's do a quick timeout here. They don't tell you anything about x, as in what quadrant it's in or anything else. So we'll just assume that we're going to use the positive, okay? We'll just assume it's in the first quadrant, okay? That makes life easier, okay? So what do we have then? Minus this times the square root of 1 minus x squared, okay? So this is what your cosine of this thing is going to be, okay? Now, for some reason, I don't know why, they bring the square root of 2 inside the other one. So they say this will be, they say root 2x. I know that's okay. I prefer to write x times root 2. If I write root 2x, I can't tell if the x is under the radical and I haven't drawn the line far enough, or if it's not. So I like to put the x in front so you know the root 2 is separate. Minus, and then here they multiply through, and I don't know why. To me, it would be perfectly fine to leave it as root 2 times the square root of 1 minus x squared, and then put it all over 2, because the common denominator was 2. But what they do is multiply this through and call it, they say root 2x. I prefer x root 2. I know they don't like it. Minus the square root of 2 minus 2x squared over 2. That's how they express it in the book, except they reverse the order and say root 2 times x. I just don't like writing that because it's ambiguous. This is not ambiguous. Okay? You write the root 2 in front, got to make sure that you've got them separated enough to tell the x's from the y. That's why I like writing the x first. They don't like it, but good enough for them. All right, that was a little bit carried away of a problem, but it works out well. Pythagorean theorem came in or Pythagorean identity came in quite well. There is a checkpoint there. It's a similar type of question. Take a look at it. Okay, I think we're ready for example 5. And here it is. And this example 5 has a little subheading here says you see LarsonPrecalculus.com for an interactive version of this, type of example. All right. It says, in the slide it says use a different formula. Here it says verify the cofunction identity. Whichever way, let's make sure we can do that. How would we go about verifying that? They tell us it is an identity. We kind of know that's absolutely true. How do we verify it? That's the cosine of a difference. How does that work? You remember how that goes? Cosine u, which in this case is pi halves, times cosine x. There, your b is your x here. And if that was it's a plus. If that were a plus up there, it'd be a minus down here. Okay, plus sine of pi halves times the sine of x. And what we're asking, is that the same as sine x? That's what we're trying to verify. Well, what is cosine of pi halves? Second?
I'm just restating it.
Okay, you said square root of 1, which is e1. Cosine of pi halves. Where does cosine begin? Second? I can't hear you.
At pi halves?
Okay. Now, cosine. There's two different things. If you're doing unit circle, it begins down here. What angle is that? 0. And it goes up this way. Okay. Well, my question was, on the graph of cosine, where does cosine begin? At 1. And by pi halves, where has it gone? To what? No, at pi, it goes to -1. Pi halves is only going to second 0. Okay, cosine of pi halves is 0. So that makes this first term the first term 0. 0 times cosine x will be 0. Plus, what is sine of pi halves? 1. So we have 1 times sine x is equal to sine x. Yes, absolutely. That is an identity. Okay, we've just verified. Okay, makes sense? All right, let me clear my chicken scratch and let's see what they do. So using the formula cosine u minus v, we have cosine of pi halves minus x is cosine pi halves cosine x plus the opposite sign here, sine pi halves sine x, just like we did. And then we evaluate it. Cosine of pi halves is 0. So this term goes to 0, that term goes to sine x, and sine x is equal to sine x. Okay? 0 times cosine x plus 1 times sine x, that's equal to sine x, and you just verified the identity. So that should make you feel all warm and fuzzy inside, right? Okay, good. We like doing that. All right, sum and difference formulas can be used to rewrite other expressions like these. Remember, we have these at the end of a problem sometimes, you know. So sine of theta plus n pi over 2, or something like that, cosine of theta plus n pi over 2, where n is an integer as expressions involving only sines of sine theta or cosine theta. And these are also called reduction formulas. Okay? So they're telling us about it now. I have a feeling they're going to have us do it on the next example. Yes. Nope, they're skipping example 6. Shame on them. So let's us do example 6. Okay. This is where we'll do example 6. Write each expression as a trigonometric function of only theta. So the first one here is cosine of theta minus 3 halves pi. Theta minus 3 pi over 2. Okay? So you tell me first step. A little louder? Yes, the difference formula. A little louder? Cosine theta. 3 pi over 2 plus sine theta. Okay. Now, we got to figure out what cosine of 3 pi over 2 is. Well, cosine starts 1. At half a pi it goes to 0. At pi it goes to -1. And back to 0 again. Remember, cosine is 0 at all the half pi's. Sine is 0 at all the whole pi's. Okay? Oh, I'm getting hungry thinking of whole pi's. Okay. So this is a 0 again, just like we had it before. So this is equal to, and what is sine at 3 halves pi? Let's start with that. Sine starts at 0, goes up to at pi halves, down to 0 again at pi, and -1 at that. So that would be negative sine theta. Okay? So cosine of theta minus 3 halves pi is the same as minus sine theta. Now, they call that a reduction formula. Okay, fine. I don't know exactly what they're reducing, but they're reducing something. Okay? So let's do the B one in that group, and that is what they got in the book. The tangent of theta plus 3 pi. Okay, tangent. Does anyone remember your sum of your tangent formula? Okay, tangent of theta plus tangent of 3 pi over 1 minus tangent theta tangent 3 pi. You could have said it the other way too. Okay? Now, so it looks like the good question is going to be, what is tangent 3 pi? If we can answer that, we can fill in the formula. Where does tangent begin? At 0. And it's not defined at pi halves. And then it goes not defined at the other side of pi halves. And pi is back to 0. So at 0 it's 0, at pi it's 0, at 2 pi it's, and at 3 pi it's 0. So it looks like that's a 0 there, that's a 0 there. So what do we have? Right? Tangent theta over 1. But kind of course that's true, because what's the period for tangent? Pi, so every pi you're going to be right back where you started from. So yeah, we do that one, okay? All right, good deal. That gives you tangent theta. And there's a checkpoint there at the bottom, which gives you a couple more to play with, which is fun, okay? Let's move on to example 7, okay? All right. Here's example 7. Solving a trigonometric equation. Find all the solutions of this trigonometric equation. Sine of x plus pi fourths plus sine of x minus pi fourths. They have been really, really, really sloppy on this problem. Okay? They need to close a bracket there and close a bracket there. Yep, that's what they got in your text. Whoever the graphics person was went to sleep on that one. Okay. All right. On the interval 0 to 2 pi. Okay? Find all the solutions for that. So how would you begin? How would you begin? Second? Yeah. These are sum for the first and difference for the second. So what's the sine of a sum formula? Sine of what? Sine x cosine pi fourths the first part plus cosine x sine of pi fourths. Okay, that's the first side, plus, and then what's sine difference? Sine x cosine pi fourths, that looks familiar, minus cosine x sine pi fourths. Okay, and this is equal to -1. Okay, so we expanded our sine sum formula and our sine difference formula and got there. What are some things we note here?
the same.
Yes. And what do you see that's the same?
The sine x cosine pi over 4.
Right. You got two of those, so we'll write down this 2. 2 times sine x. And what is cosine pi fourths anyway? Second? I think you said it right. I just can't hear. Square root of 2 over 2. Square root of 2 over 2. That just saves some writing, which also enables me to cancel out 2's. Oh, I like that. Okay. So that's these two combined. But then what happens on the other 2?
You cancel them out because they're the same, but
They add to 0. You're absolutely right. And this is equal to negative 1. Right? Now, how can we solve that equation for all x's in between 0 and 2 pi? Where's your x? So it's in the sine. So we first have to solve for sine x, and then we'll worry about solving for x. So how do we solve for sine x? Now this is a separate factor here. That's your cosine pi fourths.
well, then subtract.
Nope, those are not added. Divide both sides by root 2, square root of 2. That's it. Okay, then those go out, and that leaves you sine x is equal to negative. And how's another way to write 1 over root 2?
1
Root 2 over 2. Exactly. Negative root 2 over 2. Now, can you think of any angles whose sine is negative root 2 over 2? Any in the first quadrant? No, because it's negative. Any in the second quadrant? No. Okay. How about the third quadrant? Which one would that be? Second?
5 squared over 4.
5
5
pi over 4. 5 pi over 4. Absolutely. So x is equal to 5 pi over 4. Is that it then? Nope. Also in the fourth quadrant. And what would that be? 7 pi over 4. Exactly. The next quarter pi and that. And those are the only two in that interval for which that's true. 5 pi over 4 and 7 pi over 4. See that? All right, let me erase my writing, and let's see how they did it. Okay, using the sum and the difference formulas for sine, we rewrite the equation as sine x cosine pi fourths plus cosine x sine pi fourths plus sine x cosine pi fourths minus cosine x sine pi fourths. That's equal to negative 1. Okay? And then by inspection here, you see you got 2 sine x cosine pi fourths, but these two add to 0. So that's equal to negative 1. Okay? Now when are they going to get around to figuring out what cosine? Okay, here's where they do it. 2 sine x times root 2 over 2 is equal to negative 1. And as you see, the 2's can cancel out, divide out, and then divide both sides by root 2. And you have sine x, is equal to negative 1 over root 2, which is also negative root 2 over 2, which then goes ding, 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 ding. I recognize that one. That's my quarter pi. Sine of a quarter pi is root 2 over 2, only this is a negative. So that means you're not in the first quadrant, not in the second quadrant, but either in the third or the fourth quadrant where your reference angles is pi fourths, and that, of course, then would be x equal 5 pi fourths or 7 pi fourths, just like y'all said. Make sense? Okay. Now, that's the end of the slides, but it's not the end of the section. We have one more example, and that's example 8. So let's do it here. Verify this, and this is an application from calculus, and I'm guessing only one of you is taking calculus. Okay, too bad. It's fun stuff. Okay, but here is an application from calculus. Verify this, that sine of x plus h minus sine of x divided by h is equal to cosine x times sine of h over h minus sine of x times, they put parentheses here too, I don't think it's necessary, but I will just because they do, of 1 minus cosine h over h. Okay, there's what we're trying to do. Of course, in this expression, your h cannot equal 0. Okay? Goodness, my eyes are dry. How would you approach that to verify that identity? So itchy. Where would you begin? Okay, let's expand the sign of x plus h. What would that be? Sine x cosine h plus cosine x sine h. Okay, minus sine x over h. Okay. Now, if you'll notice, this middle term here is exactly that term. Cosine x times sine h over h. Right? Okay. Which then leaves, if you do a minus first, minus sine times 1 minus cosine h over h, which is the same. So you can write it out and expand it a little bit, but that's exactly what you get there. Okay? I'll let you write it however you want to, but that is what you got. Now, you might say, well, that wasn't very challenging, was it? It really wasn't. But here's the thing when you get to calculus. Sine h over h, you'll learn in calculus, you'll see it demonstrated why it's true. As h is approaching 0, not equal 0, approaching 0, sine h is 0, and h would be 0, so you've got 0 over 0, which we call in calculus an indeterminate form. We don't call it undefined. If it was 7 over 0, yeah, that's undefined. But 0 over 0, you just can't tell who's winning. You know, it may be undefined or it may be something else. And you'll see in calculus, you'll find out that is indeed the one. Okay? So then you get cosine x. Whereas this one here, 1 minus cosine h, again, as h is approaching 0, the cosine h is going to 1, so you have 1 minus 1, which is 0, over 0. Okay? This 0 over 0 gave you 1. That 0 over 0 gives you 0. Okay? And you have to look at that from some other viewpoint, but I'll give you a little hint here. sine x or sine h, as h is close to 0, if you picture the sine function, that's almost a diagonal line, isn't it? And the identity function, h equal h, that would be, x equal h, or y, x equal y, that would be this. And both of those, they lie on top of each other, so the ratio is 1. Whereas 1 minus cosine h, cosine h, as you get close to 0, cosine h is close to 1 all along there, and 1 minus that is going to be close to 0, and that gets closer to 0 than the denominator does. So that's still like this. So that's why the numerator wins there and makes that a 0. Now that's a real flop. So anyway, as h approaches 0, that goes to 0, this goes to 1. So whatever this is approaching cosine x. Well, does anyone know what this is? It's called the difference quotient, if you remember back in Math 112. And what you use that for in calculus is that's your first derivative. And the first derivative of sine is cosine. We've just proven something that in fact, that's the proof to show you that the first derivative of sine is cosine. You didn't need to know that, okay? But I told you. And then the checkpoint there gives you another one, which basically, will show you that the first derivative of cosine is negative sine. And you'll look at that and see that. But you don't have to. Let's do our vocabulary at the top of page 378. Fill in the blanks. Sine of u minus v. A little louder.
Sine of u cosine v minus cosine v sine v.
Exactly, sine v. Okay. Sine u cosine v minus cosine u sine v. Number 2, cosine of u plus v.
Cosine u cosine v minus sine u sine v.
Perfect. Okay. Number 3, tangent of u plus v.
Tan u plus tan v over 1 minus tan u tan v.
Yeah. Tan u plus tan v over 1 minus tan u tan v. Okay. Number 4, sine u plus v.
Sine u cosine v
Sine u cosine v
plus
plus,
cosine v sine v.
yes, cosine. Which way did you say it?
Sine sine u cosine v and cosine u sine v.
Yes, yeah, plus. That's all. Thought you reversed them both there, and I wasn't sure. Okay. All right, number 5, cosine of u minus v.
Cosine u cosine v plus sine u sine v.
Perfect. And number 6, tangent of u minus v.
Tan u minus tan v over 1 plus tan u tan v.
Perfect. Okay. So homework exercises there. Yeah, I keep forgetting I'm also should be recording this. I should have repeated those. I did some of them, but I forgot to all of them. But hopefully you'll, if you're listening at home, you should be able to figure those out too. So homework exercises here, do either 7 or 9. Okay. Both of those are at calcchat.com. Okay. Then do any of the odds 11 to 25. All those odds are at calcchat.com, 21's at calcview.com. Then do any of the odds 27 through 33. They're all at calcchat.com. Then do any of the odds 35 to 39. They're all at calcchat.com, but 35 is at calcview. Do any of the odds 41 to 45. They're all at calcchat, only 43 is at calcview. Do any of the odds 47 to 51. They're all at calcchat. Then do any of the odds either 53 or 55. They're both at calcchat. 53 is at calcview. Do any of the odds 57 to 63. They're all at calcchat. 59 is at calcview. Do either 65 or 67. They're both at calcchat. 67 is at calcview. Do any of the odds 69 to 73. They're all at calcchat. 73 is at calcview. Do either 75 or 77. They're both at calcchat. Then application problems, do 79, only one, okay? Then there's some exploration. There's 81 and 83 are true false. If you can figure out whether they're true or false and why, that would be interesting, hopefully helpful. Error analysis, I really don't like it when they print something wrong in the book, and they obviously have. They have the big red X there. Why is that not true? See if you can find the error if you want to. If you don't want to mess with that, you don't have to. Then verifying identity, do either 87 or 89, and then do either 91 or 93. You could try doing 95 and try doing 97. Okay. All right, then you can do, I think, 99, and if you want to try a proof, that's 101. All right, any questions? Okay. Let's get started. That was 5.4. Let's get started on 5.5. This is the last section before the test. So this may mean, if I can get it done, I'll try to have the test ready for you on Thursday. We may not be through with 5.5, but we will be far enough along, I think you can get started on the test. I like to give it to you before the weekend so you can work on it then. All right, continuing and analytic trigonometry. A slideshow from current slide. Okay. Now we're going to look at multiple angle and product to sum formulas. Now they also have something they call sum to product formulas. We'll look at those. Go over them a little bit. The multiple angle formulas you use all the time, okay? So that is one that, yeah, get used to those. And they follow directly from the sum angle formulas, directly from there. The product to sum formulas, you do a little bit of manipulation in a couple of different ways with Pythagorean identities and some of the other difference or sum identity, and you can get the product to sum formulas. And then you can fiddle with them a different way and get the sum to product formulas. Those last two, they're sort of fun to look at and do. And I'm sure there's some applications somewhere, but usually just look them up. Multiple angle, though, you will use a lot. Okay? So our objectives here are to use multiple angle formulas to rewrite and evaluate some trigonometric functions. And that is important. Okay? Use power-reducing formulas to rewrite and evaluate some trigonometric functions. This you do use some. Actually, you use it for some of the multiple angle formulas too. Okay, so that's sort of. And then the half angle formulas to rewrite, and those you do use a fair amount too. Maybe not quite as much as the double angle, but you actually use the power reducing to get to the half angle. I said it backwards before. And then use the product to sum and some product formulas to rewrite and evaluate some trigonometric functions. And these are kind of, frankly, just kind of made up. They are true, but not used very often. And then we'll use trigonometric formulas to rewrite some real-life models. Okay? So, sort of a long section, but let's get started. The multiple angle formulas. Okay? In this section, you'll study 4 other categories of trigonometric identities. The first involves functions of multiple angles, such as sine of KU and cosine of KU. Okay? We'll talk about how to get to those. Second category involves squares functions, such as sine squared u. Pythagorean identities come to mind. And then the third category involves functions of half-angle formulas, like sine of u over 2. Okay? The fourth category involves products of trigonometric functions, such as sine u cosine v. Okay? I think you probably can think of where you've seen that already before. That's what we'll be using here. Okay. So, it says you should learn the double angle formulas because they're used in trigonometry and calculus. Let's not just learn them, let's derive them. Okay? I want you to remind me of what, and this is fresh from the last thing we did, sine of, what do you want to use? U plus V, A plus B, huh? U plus V, that's what they used in the book, so let's use U plus V. Remind me what that is? Sine U cosine V plus cosine U sine V. Okay. Now, here's a supposition for you. What if U was equal to V? Then what is U plus V? If the two are equal, if V is equal to U, U plus V would be U plus U, which is? No, U plus. Second? Yeah, happy birthday to you. Right, okay, all right. You chose it, okay. So this would be sine of 2U. Now this is with U equal V, right? So this would be what? Sine U cosine U plus cosine U sine U. And what is that? Those are the same, they're just out of order. 2 sine U cosine U. That's what sine of 2U is. Sine 2U. Okay. Think we can do that with cosines? Let's do cosine of U plus V. Remind me what that is? Whoa! Cosine U, cosine V, minus sine U, sine V. Now we'll go back and say, what if U is equal to V? What do we have here? Cosine of 2U, right? And this would be cosine U, cosine U, minus sine U, sine U, which would be Second? Cosine squared u, right? Cosine times cosine is cosine squared, right? Minus sine squared u. There we have a cosine double angle formula. There's your sine double angle formula. There's the cosine double angle formula. Now, do we remember what tangent of a double angle, tangent of a sum angle is? Well, all right, let me write it here. Tangent of u plus v was tangent u plus tangent v over 1 minus tangent u times tangent v. Okay? Now what if u is equal to v? And this becomes tangent of 2u. That would be equal tangent u plus tangent u over 1 minus tangent u, which would be 2 tangent u over 1 minus tangent squared u. That one we don't use that much, but that's what it is. Okay? Now, let's come down to this cosine 2u. We've already derived it. That's just one expression in it. Now notice, but what does that look? Second, it looks Pythagorean in this shit, you know, but it's not quite because it's a minus there rather than a plus. But we could use the Pythagorean theorem to get this strictly in terms of cosines or strictly in terms of sine. So which you want to do first? Cosine. So let's get the sine squared in terms of cosine squareds. What is sine squared in terms of cosine squared? Second? Isn't it 1 minus cosine squared u? So then this would be cosine squared u minus a 1 minus cosine squared u, right? Which would be, I think I'll write it down here, cosine squared u minus 1, minus a minus is plus cosine squared u, and that would then be 2 cosine squared u minus 1. Okay? Now, this next time, let's get cosine squared u in terms of sine squared u. One minus sine squared u, right? Because the two of them added together is 1, so subtract 1 from either side, yeah. So now we'll do this one as 1 minus sine squared u, that will be the cosine squared u, minus sine squared u, which is 1 minus 2 sine squared u. Okay, so there we have 3 expressions for cosine 2u. Cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared u. Now we'll go to the next slide, and there they are. Sine of 2u is 2 sine u cosine u. You don't have to. You should learn them. You know how to write them, so you don't have to learn them. I hate memorizing. Okay, so that's what that one is. There are three different forms for writing cosine 2u, cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared. And then tangent 2u is 2 tangent divided by 1 minus tangent squared. We derived every one of those. Okay? And they were pretty easy to get to. Right? Oh my goodness. Did we just run over? But guess what? There'll be no extra charge. Okay? We will start next time with example 1. Okay. Did we have enough to do any new homework exercises there? Probably not. So we'll just pick up. So do the homework exercises from 5-4, and I'll try to have your test ready for chapter 5 next time. We may still be, because this is a fairly long section, we may be a few days, at least 2 days before we finish that. So that way you can get started on the first part, even if you can't get to that. Good deal. We'll see you Thursday.
After that?
All right, you too. Thanks.